Hello, so today we're going to look at special products of polynomials. So we've just looked at multiplying polynomials, and we're going to look at these products that are kind of special with it because we've looked at them before. We've seen them before. The two that we're going to focus on today is we're going to focus on the difference of squares and perfect squares. So let's take a look first of all at the difference of squares. All right, so you may recall that the difference of squares when you were working with quadratics was something along the lines of this. You might have used x and y, but we're going to use a and b today. So you've got a plus b times a minus b. And this is the difference of squares. And essentially what's happening here, if you FOIL that out, well, the first term there, a times a is a squared, and the outside terms is a times b, a times negative b, so that's minus ab. And then your inside term is b times a, which is plus ab, and your last terms is b times negative b, which is minus b squared. So of course you see the negative ab and the positive ab, they cancel out, and so you get equals a squared minus b squared. So there's how your difference of squares works. So the idea here is that we're applying this same idea to a difference of squares when we're dealing with polynomials. Essentially what we've got here is this is an a plus b, a minus b. It's in the opposite order, but it doesn't really matter. So essentially what we're looking at is this 7b to the fifth is your a. Look, 7b to the fifth is a, and your your 4b is your b, right? So that's what you're looking at right here. So you got two different terms here. The first term being 7b to the fifth, the second term being 4b, and we're still just applying a plus b, a minus b. So essentially what we can do is we can rewrite this, okay? We can rewrite this as a squared minus b squared, okay? So if we take this 7b to the fifth, right, there's your a squared, so 7b to the fifth power, and we're just going to square that. And then minus our b squared is 4b, so that's 4b, and we're going to square that. Okay, and this is now going to work as our solution. So using what we already know from our exponent properties, right? The first thing, of course, is 7 squared is 49. And then b to the fifth to the power of 2. Well, with your exponent properties, you can multiply the 5 times 2, and you're going to get to the 10th power. Of course, you could look at that as b to the fifth times b to the fifth as well, and that would also give you b to the 10th power. So either way you look at it is going to work. But of course, if you had an exponent that was bigger than 2 here, you might want to do the multiplication of the exponents. So 49b to the 10th power minus, and we've got 4b squared here, so 4 times 4 is 16, and b times b is b squared. And that's how you can use that shortcut that you already know of a plus b times a minus b being equal to a squared minus b squared. So we're going to plug that in, and we'll look at a second example. So 49b to the 10th power minus 16b squared. Okay, so let's look at one more example, and then we'll move on to another, and the perfect squares. Okay, so once again here I'm just going to choose a different color. I'm going to leave everything I've got on the board right here, and I'm just going to look at a different color. Okay, so once again, we've got our A and our B, our A and our B. Notice this is A plus B, or A minus B, A plus B. The other, it doesn't matter which order you put it in, A plus B, A minus B. Our A's are the same, our B's are the same. So that means that we can actually apply the exact same rule. So if we've got 5a cubed minus 2 times 5a cubed plus 2, that's going to be equal to, well, our first term is the 5a cubed, so we're going to say 5a cubed squared minus 2 squared. That's our second term is 2 squared. Okay, so we can solve this quite easily now. So 5 times 5 is 25. And a cubed squared, so a cubed times a cubed is a to the 6th power. And then we've got minus 2 squared, which is 4. And we can write that simply just like that. Okay, so that's your difference of squares and how your difference of squares works. Let's move on to the perfect square. The perfect square is a very slightly different rule. So let's look at that. There's your difference of squares. Let's move on to the perfect square. And of course, you've got videos right here that can help you go through them in pretty much the same way as what I'm doing for you. Okay, so the same kind of idea goes here. So let's recall our perfect square rule. So our perfect square rule, okay, it looks something like this. If you've got a, let's say a plus b, we'll start with a plus b and we'll square it, okay? And let's recall there that that looks like this. It's basically a plus b times a plus b. And so foiling that out, you get a squared, and then you get plus a times b, and then plus b times a, which is a times b, plus b times a, or a times b, right? And that's and then you finally get plus b squared. And combining like terms, you get yourself a squared plus 2ab plus b squared. Okay, so this is a nice, useful rule to use. Another one to bear in mind as well is, of course, the subtraction version. So a minus b, again, perfect square, except it's subtracted. Okay, a minus b is, of course, a minus b times a minus b, right? And that works exactly the same way. So you get a squared minus a b minus ab again, because you've got a times negative b, and then you got a times negative b here again, right? And then you get minus times a minus is a plus, so you get plus b squared. And so this version here is a squared minus 2ab plus b squared. So that's your essential rule, and you can apply that to any of the questions that you have. So let's look at the question we have right up above here. Okay. So the question we have right up above here, we're essentially saying that this here, that 5 is your a, and that 6b cubed is your b. Okay, so we're going to set this up as 5 plus 6b cubed, and it's all squared. Okay, so our rule here is our first one here, so we're going to look at this one here, right? It's a plus b squared, so we got all the positives. So what we're looking at here is we're going to have our first term, which is our a, which is 5, so that's going to be 5 squared, okay? And that's going to be plus 2 times, and then 2 times a times b, right? A times b is 5 times 6b cubed, which is 30b cubed, right? And then we've got plus b squared, so that's going to be plus, well, 6 plus, well, let's leave it as it is for a moment. So 6b cubed, and we're going to square it, okay? And then we'll tidy all this up. So 5 squared is 25, plus 2 times 30b squared is 60b cubed, plus 36b to the 6th power. Okay, so we'll do another problem. We'll take a look at a second problem here in just a moment. 60b cubed plus 36b to the 6th power. Okay. So, taking a look at a second problem here, we're going to look now at the negative version of it. Okay, so looking at the negative version, here, we're going to highlight this one here. So we're looking at a squared minus 2ab plus b squared. So starting with 2a to the 6th power minus 6a to the third power all squared. That's going to give us this, this second one, a squared minus 2ab plus b squared. So our second term must be a negative, right? So first of all, our a squared, 2a to the sixth power, let's just write that out as 2a to the sixth power all squared, minus 2 times, right? And, you know, we might want to break this out first of all. So we got 2a to the sixth power times 6a to the third power, right? Let's not actually multiply it out just yet. Okay, so just making sure you got your minus in here from here. And then we got plus our 6a to the third power all squared. Okay, let's simplify all of this. So we've got 2a to the sixth power squared. So 2 times 2 is 4. A to the sixth squared is a to the 12th. 6 times 2 is 12, right? Okay, minus, well, we'll bring the 2 in a moment. Let's go with the 2 times 6 first. So 2 times 6 is 12, times 2 is 24. So 2 times 2 times 6 is 24, right? And then you got a to the sixth times a to the third. That's adding the 2 exponents, so a to the ninth, 24a to the ninth power, right? And then we got plus 6 squared is 36, and a to the third power squared is 3 times 2 is 6, so a to the sixth power.